Hi, everybody, and welcome back. I hope everything worked out well yesterday with the derivatives that you were coming up with the power rule. Today, we're going to talk about tangents to the curves, which is one of the first applications that you would use with calculus. I thought we would start here real quick. Let's do a quick review from yesterday. So if I gave you y is equal to 7x to the fifth minus 4x to the fourth plus 12x cubed plus 6x minus 18. And I said, what is the derivative? Dy over dx. What would that be? Why don't you take about 30 seconds and come up with that? Remember, the two ways that you have to find derivatives are either using the definition of a derivative or using the power rule. So the question you got to ask yourself is this set up for the power rule? Can I use the power rule? So let's see, as I take the derivative here, my derivative of 7x to the fifth would be 35x to the fourth minus 16x to the third. My third term would give me 36x squared. The derivative of 6x is 6, and the derivative of negative 18, which is a constant, is 0. All right, so there's your derivative. So we know the formula up above would give you y values, sometimes also referred to as height or position, and the derivative down below, the second formula you work with would tell you steepness. All right, and we're going to give some meaning to that steepness here in the next couple of days anyways, but it gives you a slope. Okay, let me get rid of all this. So what we want to do today is we want to be able to take a curve that is given to us, maybe something like that, and then take a point on here. All right, and find the equation to a line that's tangent there. All right, because that line is used for several things in calculus. All right, so your job today is to come up with that line there, or maybe the point is over here, and we want a line that is tangent. Okay, so pretend those are tangent lines. So to come up with the equation to a line, y minus y1 equals m times x minus x1. There's our equation to come up with the line. We know that we need to know an x1 and a y1, which represent any point that's on the line, and you got to know the slope. Now, the slope is your dy over dx. So here's where we would use our derivative to whatever function is given to help us find out what that slope is. So let's take an example. I'll look at an example here. Find the equation of the line tangent to the curve y equals a negative 2x squared plus 5 at the point 2, negative 3. Two equations to work with. This equation tells you y's. Now, if you notice, I don't need the y this time. I already told you that y is equal to negative 3. But if I didn't give you the negative 3, you can plug x equals 2 in there and come up with that. Right? The second function that we need to work with is y prime. So why don't you go ahead and find the derivative to this function. Right, so I got y is equal to negative 4x. And let's illustrate what is going on here. So if you were to graph this equation, and it does not need graphed, but if you were to graph it, we can see this is an upside down quadratic that's moving up 5 units. So it's looking something like that. You are told that the point 2, -3 is on the graph. 2, -3 would have to be somewhere down here, and there's a line that's tangent to it. That's what we're looking for. So in order to use my formula, y minus y1 equals m times x minus x1. I have to know an x1, y1. That was given to me. And I have to know what the slope is. And that's where I'm going to use my slope formula. So in order to find the slope, it says y prime is equal to -4 times x. If x is equal to 2 and you multiply by -4, you get a slope of -8. And if I take a look over at the graph here, to me, that seems pretty reasonable to have a slope of -8 at that point. So my equation, y minus -3, which would be a +3, equals the slope of -8 times x minus 2. And one of the things we've talked about this year is you can leave lines in that slope-intercept form. In fact, when you get to an AP class, they kind of expect you to leave it in that form. If this were a multiple choice problem, maybe you wouldn't see that form. Maybe you'd have to distribute the -8 through the parentheses, bring the 3 over, all right, and convert it to points or a slope-intercept form, something like that. Okay, so point-slope form is fine to leave that. Okay, why don't we try that on this equation? Now, on this equation, all right, this is the formula that would tell me y, or f of x. I cannot use the power rule yet because the x is in the denominator. So we really need to move that to the top to get f of x equals x to the -2. So one of the things we talked about yesterday is if you want to use the power rule, you have to be able to put all your terms into some constant times x raised to the n power. So that doesn't work when x is in the bottom of the fraction, right? X has to be in the top of the fraction is what that's telling us. That's okay. We move it up to the top and we can now take our derivative. F prime of x equals -2 times x to the, remember to subtract 1, that would give you a -3. In other words, f prime of x equals -2 over x cubed. That formula there would tell me slopes. Now, this problem is a little different, all right? I need to know my x and my y. All right, I know my x is -2. I just don't know what the y is yet. But that's okay. I've got an equation for that, or up there. And then I need to know the slope at -2. And that's where this equation comes in. If you plug -2 into the original equation, you would have 1 over -2 times -2 will give you 1/4. So unlike the last problem where -2, 1/4, where the whole point was given, here you had to use your equation for y to find y. And if we come down to the slope formula, I'd have -2 over -2 cubed. -2 times -2 times -2 is -8. And this will also give me 1/4. So my equation would be y minus 1/4 equals slope, which is 1/4, times x minus -2, which is +2. And that there is the equation of the line tangent. Now notice, we didn't even have to know what that the graph to the original function looks like. The question isn't asking for that, right? It just says if you had a line that was tangent when x is equal to 2, and as it turns out is at the point -2, 1/4, then what would that equation be? Okay, why don't you try this one for me? I've given you g, find g prime, find the point when x equals -2, what the y would be, and then find the slope at -2 and write the equation that you would have. And while you're doing it, I'll do it here beside you. All right, I might be a little quicker, so you might have to pause yours. So I got g of -2 being -10. And I got the slope at -2 to be 21. And I need a little bit of room. Actually, I'll leave that on there for you. So y plus 10 equals 21 times x plus 2. -2, -10 was plugged in, 21 for the slope. And I hope you agree with me with that's a line, that's tangent. Now, don't be fooled. All right. And this problem here is just like all the rest, but coming up with the slope is going to be a little more difficult. If you notice, if we take this function here, you can't use the power rule. Now remember, this doesn't break into the square root of 8x plus the square root of 11. That's not how math works. All right, let me get rid of that. So this is one where I'd have to use my definition. There's my g of x. G of x plus h is equal to the square root of x, 8 times x plus h plus 11. And then I would plug those two into my slope formula. All right, so let's see, we're working a g of x here. So let me go to the pen. G prime of x equals the limit as h approaches 0 of the square root of 8 times x plus h plus 11 minus the original function, which is 8x plus 11 all over h. And now you, of course, would have to multiply by the conjugate. Let's clean that up a little. That was x plus h. All right, in order to evaluate. So I'm going to move to the next page. The limit as h approaches 0 of the square root of x times x plus h plus 11 minus the square root of 8x plus 11 over h. Your conjugate would be the square root of 8 times x plus h plus the square root of 8x plus 11. Whoop, I lost my plus 11 here, didn't I? All over the same thing. Square root of 8 times x plus h plus 11 plus the square root of 8x plus 11. All right, so that gives me the limit. And just like I think I said the other day, there's a lot of arithmetic that's going on here. And it's not overly difficult, just a lot of it. On the top, that's where I got my conjugate. I got to multiply. So let's FOIL. The radical times itself is 8 times x plus h plus 11. The inside and the outside terms cancel out. And my last terms, and here's where you got to be careful, you've got a plus times a minus, which is a minus. And then you have a radical times itself, which is 8x plus 11. Right, so you're subtracting that whole quantity. And in the bottom, I've got h times my conjugate, 8 times x plus h plus 11 plus the square root of 8x plus 11. All right, now we're trying to plug in h equals 0. You can't plug it in the bottom, just like up here, I couldn't plug it in. All right, so let's simplify a little bit. Change colors one more time here. I would have my limit as h approaches 0. On the top, I've got an 8x plus 8h. So I've got 8x minus 8x would be gone. I've got 8h, no, they're like terms, that's going to stay there. And I've got 11 minus 11, that's gone. In the bottom, I have h times the conjugate. Now, just to save space, I'm not going to write the whole conjugate out. But you can copy it down. All right. The limit as h approaches 0. Are you going to cancel? Sorry, had to get a drink of water. H here, cancel with the h here. That's going to leave me with an 8 in the top. And in the bottom, I just have my conjugate, right? Which was the square root of 8 times x plus h plus 11 plus 8 x plus 11. And I know you're not going to be able to read that. But now I can plug in h equals 0. All right, so I'm going to erase this because I need the space again. All right, so I have the limit. I'm going to write it again as h approaches 0 of, on the top I had an 8. On the bottom I had the square root of 8 times x plus h plus 11 plus the square root of 8x plus 11. Right? And this is the point where I can take h equals 0 and plug it in. So if I substitute it in there, right, we have, boy, that was ugly. If I substitute in there, we have y prime equals 8 over, if I plug 0 in here, I'm left with the square root of 8x plus 11. There's nothing to plug in here, so plus the square root of 8x plus 11. Which leaves me with 8 over the square root, well, I've got one of them here plus one more, 2, square root of 8x plus 11. Or in other words, because I can reduce the 8 and the 2, 4 over the square root of 8x plus 11. Wait till you learn the shortcut to this one next year. You're going to love it. Now, that's my slope formula. That's a lot of work for the slope formula. I mean, I went through 3 pages here. You can see there was a lot of arithmetic, a lot of things to pay attention to. Do your best on these. Right? That's all I can ask. Right? And it is a lot more difficult without us actually being in class where we can talk a little bit more about this. Now, the problem said, what is the tangent line, all right, to this function? So I know x is equal to 2. I got to plug 2 into the original function. All right, so let's see. I need to, yeah, I didn't have that. I'm going to erase that. So my two functions were g of x equals the square root of 8x plus 11, and g prime of x equaled 4 over the square root of 8x plus 11. And we wanted to know what happens when x was equal to positive 2. So in my function g of x, we need to know what g of 2 is. You can go ahead and substitute 2 into the equation. I think that gives you the square root of 27, which if you do a good house, bad house, would be 3 radical 3. So you have the point 2 and 3 radical 3. G prime of 2, my slope, would be 4 over square root of 27, or 4 over 3 radical 3. So the equation we're looking for is y minus y, 3 radical 3, equals the slope of 4 times 3 radical 3 times x minus the x, which is 2. That is a crazy equation. And you can see exactly why in calculus class you're usually told to leave it in the point slope form. Not that you couldn't simplify this, but it's going to be a pretty ugly answer, and you're going to have a lot of unlike terms to try to finish it with. All right, so again, this is the first application that we have with derivatives, and all you're doing is finding the equation of a line that's tangent. Some problems are going to be a little more complex, like one like this where I'd have to use the definition. Some of them are going to be a lot simpler because all I got to use is the power rule, and I can very quickly find the slope. And really, that's what it's going to come down to. How fast can you find the slope? Can you use a nice shortcut like the power rule, or do you have to go through the definition like we did on here, all right? And that's going to take longer. Now, there are other shortcuts, all right? And in fact, this one here, I think I mentioned, there is a shortcut for it, but it's several months into a calculus class before you actually learn it. Okay, your homework tonight, all right, again, you should have the link, all right. It is a worksheet, and you're looking for the one that's called Tangent to Curves, all right, Tangent to Curves. Good luck, and we'll talk to you again in another day or so.